Thank you for joining us. My name is Carrie Smith, and on behalf of Cumulus Networks, I'd like to welcome you to Unleashing the Power of Open Networking. Presenting today will be Srijit Mukherjee and Aurelie Fonteni. Srijit is our VP of Engineering at Cumulus Networks and has been in the data center industry for the past 25 years. Most recently, he was the Director of Engineering with the team that delivered the highly successful VIC adapter line in Cisco's UCS servers. Aurelie runs product marketing at Cumulus Networks and has been in the networking space for 14 years. The webinar will be about 30 to 45 minutes. We will answer a few questions from the participants at the end if time permits. For those of you interested, you have the opportunity to ask questions during the webinar by using the window marked questions. Simply type in your questions and click send. You can also tweet us your questions, and our Twitter handle is @Cumulus Networks. And with that, I'd like to turn this over to Srijit really quick. If you guys, I opened up a poll, so if you guys would take a few minutes to answer that, and then I can go ahead and show you the results. And Srijit, excited to have you.
Hi, I'm Srijit Mukherjee. As Carrie said, I have something to do with engineering over here. So let's talk about sort of the promise. One of the themes or the tenets that Cumulus Networks was built around was that the data center has evolved and is evolving and will continue to evolve. But one of the most important changes that has happened is that the blueprint of a data center has changed. So I hit next. And if you look at sort of how the data center has evolved for most of the large-scale customers, which are the easy examples to hold up, the problem has been that things are just taking too long to deploy. And today, that deployment bottleneck is on the networking side. It's not on the compute or the other infrastructure pieces, if you will. So if you look at the networking aspect of things, traditionally or historically for a long period of time, the networking aspect has sort of followed the client-server model, right? Networking has always had this concept that it is the disaggregated distributed solution. However, there's a difference between a client-server network infrastructure and what today modern cloud infrastructure looks like. And we'll go through what it means to sort of make it a cloud scale solution. But fundamentally, the thing to appreciate and understand is that today's networking was built for sort of the last decade of client-server application growth. And where clearly the future is pointing is to point towards the cloud solutions that are predominating the industry today. Now, it sounds like a pretty easy statement to make, but it turns out it's not. It turns out that there are, the usual actors in this picture. There's people, there's process, and there's technology. The technology has to evolve such that you can actually do things in a very, very high scale and be able to manage it and make sense and not lose your mind. The processes have to evolve because, today you might actually have a document chain of control to get a VLAN approved, which may or may not work in the new paradigm that we are aiming towards. And of course, at the end of the day, there is the person, as Martin Casado once said. The hardest thing to change is people's attitudes and people's expectations. So the important thing is how do you go from sort of the picture on the left, the client server, today's or yesterday's model, to this cloud solution for tomorrow. And as existential proof or as proof that that is the thing to do, you can see the logos, and I suspect everybody on this call and on this webinar is very familiar with those brand names, and that's exactly what they are doing. They've basically said that tomorrow's data center, which is for them yesterday's data center, but let's go with that for a second. Tomorrow's data center is going to be built around a vendor-independent, highly automated solution that gives you OpEx savings. I mean, the fundamental point here is not whether it was cheaper to build this the first time, because that's a cost that you'll pay once and not think about again, but whether in the grand scheme of things, the operational model is something that's both scalable and affordable for the capacity that they need. And this is sort of the fundamental driving force behind Cumulus Networks worldview with respect to networking. So at a very high level, right? I mean, for people who've been doing this for a while, this slide is mostly statement of fact. Today's applications and networking is very tightly coupled. You want to move to a model where you can change your network infrastructure without needing to rewrite your application. This is kind of a very simple statement, but in practice, not the easiest thing to see happen. Networking needs to be multi-vendor. You need to have your solution such that you don't say, oh, if I was to change my vendor tomorrow because that pricing wasn't right or they weren't on the right technology curve or whatever the issue might be, I have to change my entire application stack, which is where things are today for the most part. Clearly, in this new world order, east-west traffic is hugely dominates any north-south traffic because most of the computational benefits is gained by having the nodes be able to talk to each other. We can go through the rest, but I guess most of it is kind of obvious. The last one, I think, is the thing to sort of latch on to, which is if you think about what it takes to deploy, think about all the last few major data center innovations and what it has meant to induct that technology into your data center. It has required porting. It has required you to go and write an application infrastructure. It has required you to go write an orchestration infrastructure. It has required you to understand, let's say it's a controller, how to integrate with the controller. Inducting that technology into your data center has required you to go write code or do something that was not core to your business and not part of your core competency. And according to our worldview, the automation tools and the model that automation tools will use need to be something that is completely vendor agnostic. It needs to be something that you could run on your laptop, on a VM. And if you can prove that this works, then you go and deploy it onto the quote-unquote networking hardware, and it should just work. Maybe that's an unachievable ideal, but that should be the direction in which things are pointed towards. So I guess we lost the animations on this. So then like changing tracks to see what does it mean, right? So you think about on the compute side, over the last, I would say, 2 decades, there has been continuous evolution and churn up to the point where every component, whether it be the x86 CPU in the core or technologies like PXE in the way servers are brought up, to all of sort of the adjoining technologies. It was, in many cases, it wasn't the single best performing or technologically most advanced solution that has become the norm of the industry. But the defining characteristic of things that have become norm in the industry has always been simplicity and transparency, that people understand how it works and everybody can use it and implement it. One of the things we discovered in the process of trying to get equivalency in the networking space was that in 2012, we were walking around wondering why there was no networking standard for doing installations of networking gear. No direct corollary to PXE on the compute side. So we, along with OCP, we came up with this concept called ONI, the Open Network Install Environment, which allows you to, as the slide shows, achieve equivalency to the point where your network device, your networking switch, so to say, can effectively go through the same boot, provision, OS install, and operational applications phases as your compute server. And you need this because if you do not have this, it means that you have a break in your workflow where if you were going to scale out your compute, its corresponding networking elements would not be scalable from a workflow perspective. Next. And fundamentally what that gives you, the idea is that you want to eventually get to the point where you have a data center that is operational, that has the ability to operationally scale out, as shown on the x-axis, but also gives you the flexibility to deploy on the y-axis. And what that means is you might decide tomorrow, or actually said a very different way, the characteristic of a modern data center that I think is has been well established is that you're going to deploy complex applications on generic infrastructure. This infrastructure needs to be able to provide you two very specific characteristics. The first is that the infrastructure will never run out of gas. So you don't go, shit, I need to get one more server going and I need to redo my entire data center. That's a situation you never want to get into. And you also don't want to say, hey, you know, I used to be using Microsoft SQL yesterday, and today I want to move to Hadoop, and now I need to redo my entire data center. So these two axes are very important to how your data center is built. And today's networking infrastructure, I would argue, doesn't give you that complete flexibility. And if that's the end goal, what you want to be able to do is, as I said, build out your scale infrastructure such that it's a repeatable, well-understood process, and you want to have your flexibility to be able to deploy a whole variety of solutions, whether it be controllers for managing your virtual ports, whether it be monitoring solutions like Ganglia or CollectD, whether it be orchestration tools like Salt, Ansible, Chef, Puppet, name the tool that you want. All of them should be able to play. So so then now we have to solve the problem, right? So now if the problem statement is well understood, you have to get around to solving the problem. So the way we looked at it, we see the world as sort of coalescing around a few standard use cases. There's the virtualized server and networks use case, very simple, well, not simple at all actually, but well understood. Workload mobility is very important. Reconfiguration QoS is very important. There's the distributed storage MapReduce problem, which is very popular in the large-scale data centers today, characterized by east-west traffic, lots of uneven traffic flows. Incast is a huge problem. Lots of different storage solutions that are overlaid on top of this. And similarly, the storage guys are also taking advantage of this concept of disaggregated anonymous hardware. And then there's the supercompute or like the big data type of operations today. Again, east-west traffic, low latency is important, and so on and so forth. You look at sort of what are the commercial angles, and Orly will cover that in sort of the second half of this talk. There's the commercial applications around Hadoop or around VMware's highly successful vSphere product line. There's OpenStack, which is a big emerging force in the data center space. The thing that you recognize if you squint your eyes and think about this is that a lot of networking companies talk about how their APIs are the perfect answer or their architecture is the perfect answer and so on and so forth. Our assertion is it's neither of those. The most important thing is that it's about choice, that you, as shown in the slide before, you need to be able to come in and say that in my data center, I've built a solution where all of these workflows can be deployed because you as a company might need to use some collection of these available options. But your infrastructure has to be such that it's not locked in, that it's not tied to one particular use case that you had envisioned when you signed the PO. So next. So this is sort of the problem statement. Now, what is the solution statement? Next. The solution has to be that you get the best of breed of everything that you can get. So I guess not having animation is making this slide a little bit interesting. So if you look at sort of historically what has been deemed as enterprise-grade networking, it looks more like the picture on the left. There is, of course, there is the underlying layer of hardware. There is a layer of an operating system inside there. Often the operating system mostly works like a carrier. It configures your CPUs and your memory, and it gives you a shell and gives you a scheduler and an infrastructure to write device drivers in. And then you have the applications that do the core function of routing, even the networking stack, if you will. And this picture on the left is very similar to what a computer system looked like in the 80s. I mean, maybe that's not even fair, but in the 80s, you got a single box from a Sun or an SGI or a Digital or an IBM, and it came with everything in it. It had its own choices for everything that you could buy, including the hard drives in the system. And what what we are promoting and what we are positioning is that that's kind of a flawed model. What you can't see in the slide because it's animated and that big green banner is supposed to show up at the end is that the progression in our worldview is that you start with networking hardware. You have something like ONI around it that gives you the ability to now say that my bare metal switch or device can accept any kind of operating system on top of it. One of your versions of the operating system might be a full-flavored stack like ours. It might also be a very, very lightweight OpenFlow agent if that's the direction you want to go into. But the choice and the ability to deploy your own requirement is important. So then once you have the hardware, the next layer is the operating system. And the operating system fundamentally is not a networking characteristic or a networking feature set. It's a service set. It's a bunch of functions that the operating system provides, just like it does on your laptop or on your server, to the application space that says, here's how things work. But also, and in our opinion, also importantly, or as importantly, it provides a model that you can reference. So when you want to know how does ARP work, or what happens when I send a packet out on this interface, the operating system provides the reference golden model. That's what you ask, like, how is this supposed to work? You go look at the OS and you say, okay, this is what the OS says it should do. And it becomes the anchor point for your final piece, which are the applications that do your actual networking for you, whether it's an STP stack or it's a routing stack or it's some homegrown solution that tries to manage ECMP groups to their particular liking. That becomes an application problem, and the only expectations that the application has is a standardized way to interact with the operating system and thus express its requirements and its output. So, given that theory, that's all nice and good. It has to be something real. And one other thing that that I think is worth noticing and pointing out at this point is, you think about what it has meant to be an open solution on the compute side. And you think about what were the defining characteristics. The defining characteristics was when you looked around and you said every major compute vendor was shipping a box that had x86 CPUs in it and had a fairly generic sort of system layout, and most generic devices you could buy from Fry's or from whatever your favorite computer parts store happens to be in your geography, plug it in and have an expectation that it'll mostly work. And then the enterprise version of that would be a hardened, solidified solution with a very well-defined qualification and certification list. We believe that that time has, and those indicators are there on the networking side. So what you're seeing here is what Cumulus Linux's hardware compatibility list looks like. This is only the 40 gig, the 32 by 40, I think, is what we are showing on the actual boxes. You can see there are multiple vendors here and multiple system providers and a whole bunch of other peripheral device vendors like cable guys like Tenji Tech and JDSU, etc., and Finisar as well. But I actually recommend going to that URL at the bottom of the slide, and you'll see that this is just a sampling. The actual number is like 18 devices. They're all running the same OS, and they all fundamentally have been made to look identical when running under Cumulus Linux. So then let's say we've addressed the question of, is there an ecosystem? And if there was an ecosystem, what does an operating systems company do? But there's more, obviously. So the more part is that we basically need the entire workflow, not just the deployment, but deployment and beyond, to look more like a server. Now, clearly there are some real challenges here. Most networking devices don't come with like a 2 terabyte hard drive. So there are some realistic workflow issues that we have to deal with. In most cases, the workflow models will look more like the early 90s than they will look like today from a server compute side. But we are working on it, and we made great progress, and we will continue to make good progress on this. But a very important aspect of that progress is to deal with your system as a package-based system, not a binary blob, not just the things that we said about breaking and disaggregating the system applies even to the actual software that's running on the system. It cannot be a single monolith. And the idea is that, as you can see how Cumulus Linux is structured, we have the main package that gives you the reference box. It defines and characterizes what a box should do. Obviously, we have updates, things that represent either security patches, functional patches, hot fixes, things that we found. And they can all be added or deleted from your system and customized to your liking. Now, you can have a workflow that says, I'm going to customize my gold image and ship them all out using ONI to every one of the endpoints. Or you can say, I'm going to live manage them because that's what my server guys do, that whenever a new Fedora or RHEL or whatever else, or Windows Server for that matter, update comes in, we do a rolling update with some planning around it, and I want to do the exact same thing to my switches and my networking devices. However you do it, the moment you say that I can interact with them as a pure package, a lot of other options come on the table from a workflow perspective that become very, very real, right? You want to just upgrade your routing suite, you can actually do it without having to reboot your box. It's just the routing package that gets updated, and you're off to the races. Next. Now, that said, so far we've talked about sort of mostly generic things. What we found, one of the things that Cumulus Networks discovered in the process was that it's great to have an OS that does everything, and openness is fantastic, but there are a few things where I like to say we didn't need to reinvent the wheel, but we had to smoothen the ride. We had to make it such that things were easier to adopt, deploy, and employ. And we talked about ONI at great length. It's an important component because if you had something like ONI, you could deploy something that, we have something called zero-touch provisioning that allows you to basically say, take your switch out of the box, plug it into the rack, plug in the power cable, go to your DHCP server, configure the MAC address and the package you want installed, and press a button, and the switch comes up and it's ready to go. You make some mistake, the switch gets into some unrecoverable state, press another button, the switch reimages itself and comes back, a lot like how the throwaway server farms are used by these really large deployments. IF up-down 2 was another example of something that we did where we changed the way interface management worked in Linux, or specifically in the Debian distribution. And IF up-down, which is the most popular package we could find, where associating VLANs to bridges to ports was this highly fragile and incredibly painful solution. And while it worked great for like 2, 4, 8 interfaces and maybe a few hundred VLANs, when you're talking about an industrial grade network, it didn't work so well. So what we did was we came in and said, okay, let's make it something that you can parameterize, you can use modern tools like Python, you can use templates and generators and make things a lot simpler to use. PTMD, I think we've done a webinar on that in the past. I'm going to not talk in great detail about it, but fundamentally it allows you to say, if I have a highly disaggregated solution, like we talked about, I can validate my network. I can find out if my network is connected and wired and operating the way I expect it to be. And I can make every one of my nodes cooperate to tell me the story rather than build a giant honking controller. Unnumbered interfaces, unnumbered interfaces we've talked about from a routing perspective. It's not new. Cumulus is not the first or even close to the first company to talk about it. But the open source tools were lacking that particular capability, or specifically Quagga was lacking that particular capability for their OSPF implementation. So we added that to OSPF. We are doing similar things on the BGP side as well. VTEP, such that VXLAN could be integrated into hardware offload on an expedient basis, allows you to go and build virtual networks on top of physical networks, and thus further enable you to have a highly scalable and automated network. And this is the reason to do it. right? Provisioning goes from days to minutes. And it's not just, I know the slide actually says traditional versus the automated way, but there is a little bigger nuance here, right? The automated way has to be around a fairly standard and open reference. You need to be able to try shit on your laptop on your way to work and be able to deploy it rather than go buy $1 million piece of equipment just so that you can find out if your deployment strategies are going to work. That's a small nuance, but in an operational sense, it can actually have a deep impact. And I think that was the last slide, right? Next. Some more. And so you put it all together, right? So this is the ecosystem we are playing with. If you go from the bottom up, like we said, industry standard hardware, multiple vendors, multiple flavors of devices, all running the same operating system. The operating system providing an abstraction such that everything that's running on top can deal with the underlying system as if they were all the same. And then you have all of these sort of application spaces. Some of them are tools, some of them are solutions that you can see ranging from routing all the way up to package solutions like storage or big data with Nutanix Core 8 or Hortonworks. All of the solutions in between are things that we actually have. I mean, these are not just pay us $50,000 and we'll put your logo up, but these are things that we have actually working either at a customer site or on our workbenches or on our partner sites. So this is not a small thing, right? It's something that I will honestly say has been a surprise for us even as to how quickly things have turned. And some of our vendors have actually been able to, or partners have been able to make humongous progress, in fact, in some cases, get to the end without any intervention or any interaction with us. So with that, I think I'll stop talking about the overall architecture and we're...
Thanks, Srijit. That was great. Really quick, I want to open up another audience question, and then I'll show you the results, and then we will move on to Orly section. So I'll give you guys about 15 more seconds to answer this. And then, let's see, there's the results. Okay, 5 seconds, and Orly.
Thank you, Kiri. Thank you, Srijit. So far what we've covered is we've covered the requirement for new data center blueprint, and we've covered open networking benefits. And what we're going to talk about now are the recent announcement around Cumulus Linux 2.5 and how we are making it simple for organizations of all sizes to adopt open networking with Cumulus Linux 2.5 and related tools and services. So if we step back and we look at the current adoption of Cumulus Linux, we started with one of the largest web-scale provider, and it's been in production for over 2 years now. And along the way, we've seen a lot of traction. We have seen a lot of traction starting with cloud and hosting providers, and then a lot of high-tech and SaaS providers and service providers. And then along the way came a lot of education and research labs, and of course enterprises. And as time goes, we have more and more interest from enterprises because they're recognizing the power of open networking. And they are also recognizing that open networking is now widespread. It's not an anomaly. In fact, if you're looking at the latest report from Del Oro, you can see that white boxes constitute number 2 in terms of port share by far for 10 gig fixed data center switches. So what our enterprise customers are asking is they're asking for help from us to take them to the modern data center network. And this is exactly what Cumulus Linux 2.5 is about. So we are easing cloud adoption with Cumulus Linux 2.5. There are some tools that are already available today that we are enhancing, and some that we are adding with at the same time of the release, so that we make it easy through all the phases of adoption, whether it's through trials, through design, procurement, training, deployment, or support. And this is really what you can see here. So first, we have in the first phase, we have trials that's available for free through remote workbenches. And so we make these available to you. And then what we are doing along with 2.5 is we're bringing new validated designs for new design patterns that we've seen our enterprise customer adopt with modern data center networking. And that's specifically for VMware vSphere, big data, and OpenStack environments. We are making it easier to procure open networking technologies by enhancing our global reach, adding new partners, and easing procurement. We are adding to our offerings training and consulting services so that we can help you deploy and design your environment. And we also have excellent 24/7 support that's available. And our support covers not just the software, Cumulus Linux, but also we do end-to-end support. So starting with what's really new with 2.5 and the validated solution design, what we're providing with Cumulus Linux 2.5 and the validated solution design is a starting point for customer deployments. So you get designs that are tested for the management and the data paths, and we provide you the step-by-step configuration files and templates for this validated design. So as a result, it simplifies the transition towards modern data center networking architecture, towards the transition to Cumulus Linux and open networking. And we provide you some migration and simple integration point into your current architecture. And overall, it lowers the risk associated with new deployments. Along with these new validated solutions, we are adding new functionality to Cumulus Linux 2.5. And this functionality is specifically in the context of the new solution that we are bringing. So until now, if you're looking at the first two releases that we've had with Cumulus, two major releases that we've had with Cumulus Linux, 1.5 and 2.0, and so those were covering modern data center networking with IP Cloud Fabric for scalable environments, and with network overlay as well. So we started with IP Fabric so that you can get simplicity of configuration, automation, troubleshooting with affordable capacity, and you could scale out your environment. And along with that, we added integration with network overlay. So Cumulus Linux Cumulus Linux is actually a gateway for VMware NSX, and it also integrates with Midokura, such that you can integrate with network overlays on top of IP fabrics. Now, one thing that we did not have major coverage on before was layer 2 overall architectures. And as we start adding solutions around new design patterns such as VMware vSphere, we recognize that there's a need for layer 2 architecture, specifically for install base and also for migration. So we are adding layer 2 network architecture with Cumulus Linux 2.5, and that is specifically adding features such as MLAG, L2 scale, and first-hop redundancy protocol. routing protocol. So that will enable an easier migration and an easier drop into the existing architecture. Along with that, the three validated designs that we provide are, the first one is for virtualized server environment. So if you're looking at the virtualized server environment, we are going to start with VMware vSphere. And in the context of VMware vSphere, it's the dominant hypervisor platform for enterprise. Server virtualization provides a choice of industry standard hardware and a rich ecosystem of automation tool and services to manage the compute and the storage. So it just makes sense to also expand this all the way to the network. So now you can have, we can enable SDDC not just across the compute and the storage, but also all the way to the network, so that you can get choice of industry standard hardware and a rich ecosystem of automation tool and services across the entire infrastructure. The solution guides that we have and that will be available with Cumulus Linux 2.5 before the end of the year, they cover brownfield and greenfield environments. Again, if you look at traditional VMware vSphere environments, they're typically deployed in L2 network with MLAG. So this is the functionality that we are adding with Cumulus Linux 2.5. And then we are providing a simple migration to L3 Cloud Fabric, and we already have integration with VMware NSX for network overlay. In addition, so the second validated solution that we have and that we provide is in the context of OpenStack for cloud orchestration. So with OpenStack being the dominant cloud platform widely deployed in public and private clouds, it makes a lot of sense for new data center blueprints. Typically, so if you're looking at OpenStack, it's about leveraging the best-of-breed open source solution blocks. And the cloud-oriented infrastructure are typically leveraging bare metal and automation. So with Cumulus Linux on top of bare metal switches, the two solutions combined work very well together. You can get resource automation through OpenStack for virtual resources, and leverage Linux tools for automation of physical resources. So with Cumulus Linux, for instance, you can use the likes of ONI, zero-touch provisioning, and integration with tools such as Puppet, Chef, or Ansible to automate the physical resources and add capacity very quickly. So we support a variety of OpenStack solutions in conjunction with Cumulus Linux. Some of those solutions are in conjunction with OpenStack distribution partners, network overlay partners, and also we have custom OpenStack solutions that our customers can take advantage of. And for the validated solution that we're going to provide, it is based on OpenStack iSaaS. And since layer 2 networking is the easiest way to start with initial deployment, the validated solution is going to cover L2 networking. And then we have an easy way to progress to the next level with VXLAN support. And then moving on to the last validated solution that we have with Cumulus Linux 2.5, it's for big data environments. Hadoop is the leading platform for big data analytics today. So that is the solution that we are providing, and we are providing the solution together with the Hortonworks data platform. It's 100% open source enterprise-grade distribution. So it works very well with Cumulus Linux. And with big data being the leading example of modern application deployed with modern data center infrastructure, it really works very well with Cumulus Linux. So it provides, with Cumulus Linux, you get affordable capacity based on bare metal hardware. So now you can get that for your entire big data infrastructure, not just for the server environment and storage, but also for the network. You can leverage a scalable IP cloud fabric so that you can scale out your architecture. And when you're looking at a big data environment with a few servers up to tens of thousands of servers, you can start small and scale out very quickly with affordable capacity and scalable IP cloud fabric. And then to scale and efficiently manage this environment, you can leverage automation and you can have operational consistency end-to-end with Linux tools that work all across the infrastructure. Also, Cumulus Linux being Linux, you can easily customize your environment, and one such example is to use Prescriptive Topology Manager for locality optimization with Linux and big data. So to summarize, with today's presentation, what we've covered is that open networking with Cumulus Linux really enables the selection of best-of-breed ecosystem and also enables a lot of savings with CapEx savings upfront and significant OpEx savings through specifically automation and risk reduction and other tools and Linux advantages. And Cumulus Networks can partner with you on your journey to the modern data center. We offer validated solutions. We offer a remote workbench, and we offer starter toolkits for automation. So with that, if you want to get started, these are a few pointers to the Cumulus workbench and to general information so that you can learn more about Cumulus Networks. We have regular webinars, and those regular webinars are also recorded. So if you wanted to learn more about some of the topics that we've covered in the past around PTM, automation, L3 scale, etc., you can go back and check the videos on our website. And then for more questions, you can either stay in touch on our Twitter handle or send questions to sales@cumulusnetworks.com. With that, I'll just send it up to Carrie.
Great. So just one more poll, and then I'm actually going to open up. We have a lot of great questions coming in from the audience, so I want to first thank you guys all for your questions, and I want to go ahead and ask Orly and Srijit the questions that are coming in. First question, do you have specifics in terms of CapEx and OpEx savings?
So in terms of CapEx and OpEx savings, it's really dependent on criteria because it's going to be dependent on what each customer is doing. Now, if you're looking at CapEx savings, we've seen somewhere between 50 to 80% of savings. So you can, I actually have an example. Let me actually show you this example. So if you're looking at the difference, speaking, if you take an example with a switch, which is a 48-port of 10 gig switch with Trident 2, and you look at a Cisco versus Arista versus open networking comparison, those are the prices that you would see after a 60% discount from hardware from a Cisco and Arista versus open networking, which are web prices on bm_switch.com. And the CapEx savings are not just about the price of the hardware or the switch. It's also the differences in terms of optics prices. that is multiplied by the number of optics that you're using in your environment, and also the twin-ax cables and the support. Now, this is only about CapEx. The bulk of the savings is not really on the CapEx. What we find out is that the bulk of the saving is actually on the OpEx side, and OpEx side through automation. So what we have in terms of OpEx savings is the best examples are actually the specific that we've seen with our customers. We have case studies that are available online, and some example are, for instance, at UTSA, there was a 4 to 8 times operational improvement around the provisioning. And as our largest web-scale provider, what you can see is as the number of devices grew, the number of network engineers did not grow, so that also amounted for very high savings. But also, what's very important is to eliminate the risk for error. So we have features and innovations such as PTM that make sure that we eliminate risk. And one more thing I want to mention is if you Google democratizing bandwidth, we have a blog that JR wrote around CapEx pricing. So if you want to look at CapEx, you can look at that. And again, OpEx pricing, the best source right now would be on our case studies.
Great. Let's see. So a lot of great questions. How can we make apps for Cumulus?
I'll take that. So, I mean, there are no, and that's maybe something that I should have addressed, there are no apps for Cumulus, right? So clearly Linux has many variants, and it's a moving target because it moves and gets upgraded and changed all the time. Our base distribution is Debian-VZ. We were based out of that. We've changed quite a few things since then. But for the most part, an application that's written against Debian-VZ is almost definitely going to work. Things that will not just work will be things where you are looking for the ability to identify a Cumulus Linux release or something like that. The Workbench would be the place where you can try out those things and be assured. But that's the polishing touch in some sense. If what you're doing is fundamentally manipulating Linux constructs, interfaces, routing tables, that will be highly portable and will just work from a VM running on your laptop onto a deployment on an x86 CPU card-based switch. If it was PowerPC, you have to cross-compile for PowerPC, and we have some tools on our website that will help you do that as well.
Great. And Srijit, I think this next one is for you as well. What is your MLAG technology, and is it Cumulus proprietary?
So one of the sort of the overarching thoughts, and I should have covered that in my smoothen the ride part, is that we are not trying to build technology that ties customers to us. It's a strategic statement from us that we want Linux to become an enterprise-grade or business-grade solution. So what we've done with all of the other things that I had on that slide, whether it's PTM or IFAB down to or whatnot, most of those things are being submitted to the upstream projects. MLAG is a little bit different because there isn't a good upstream container in Linux that it could go into. Linux doesn't have an MLAG solution today. But what we've done is we've built our solution to be, it's fundamentally a bolt-on technology. It's built on top of standard Linux constructs. When we need multiple MAC addresses, for example, we've used a standard Linux MAC VLAN driver to get us multiple MAC addresses. We've used the standard STP stack, which is all contributed back to the MSTPD project. And the specific MLAG agent or MLAG daemon is only available on Cumulus today, but it's written in Python. It's actually transparent and visible to any and all that have access to the Cumulus installation. And going forward, we are going to make it, and we are going to drive all of the underlying constructs into the Linux kernel that's already underway, such that given our sample implementation and the fact that all the infrastructure exists in the kernel, it will definitely not be a closed solution, and it will definitely not be proprietary to Cumulus.
Great, thanks. And then the next one, this is more of an open general question, and possibly an opinion. Are network administrators open to working with true Linux interface?
I don't think that question can be answered.
But one of the things that we're doing is, as network administrators realize the need for scale and automation and leveraging tools to scale out the architecture, they're realizing that Linux is the great interface for that. And so what we are doing is we're enabling them to do that. And that's why really we have Cumulus Linux 2.5 to ease the adoption of Cumulus Linux. And that's why these validated solutions that we are providing and the toolkits around it are really making it easy for everyone to deploy it.
Perfect. Is this solution based on OpenFlow standard?
No. There's actually, that question has more questions for me than answers. We are not providing a solution. It's an operating system. So you could write an agent on top that implements OpenFlow if that's what you need. But the fundamental question is, we don't have a client-server remote controller. It's an operating system that provides the underlying switch as a generic, as a networking device, and effectively a Linux networking device. Well, how the actual device works is abstracted away. So if you are trying to implement an OpenFlow controller using, let's say, Linux IP tables, so you take all your OpenFlow commands and create IP table rules out of them and stick them into hardware, then yeah, it would be an OpenFlow solution. But we natively are not subscribing or subscribe to the OpenFlow solution strategy. And that's something that if you guys want, if the question asker wants to take as an offline conversation, we would be happy to engage on.
Yeah, and really if you're looking at the fundamental things that we're doing is we're really providing an operating system, and that's really Linux for the network. And we have a disaggregated stack for it, so it's a different solution than the OpenFlow solutions or OpenFlow model, and we are addressing different problems. We can basically address the entire network as it is right now.
Great. Next question. As a network architect, what level of knowledge is needed on Linux to run Cumulus devices? Any recommendations on Linux certificates, or usually Linux knowledge is learned via Cumulus network device test and exposure?
I think this question is, again, back to the previous question, is very similar to the previous question in that Cumulus Linux 2.5 is going to help through validated solution guides so that people can actually follow step by step. And then we have training also that helps to understand Cumulus Linux and to get up to speed on that.
Right. So, I would strongly recommend our training program. In fact, that question pretty much is the reason why our training program exists. It's sort of almost more Linux-centric than Cumulus network-centric, because the idea is that Linux by itself is a fairly strong, stable, and precise networking model. All that is missing, in some sense, is the ability for people to be able to access and understand and digest what interacting with the model entails, specifically if you're looking at it from a, here's how I used to do it, how do I do it in the future perspective.
Yeah, and you can actually send, if you're interested in taking a training, the best way is you send an email to sales@cumulusnetworks.com, and then we can provide you the right resources for that training.
Great. Next question. What does it take to port OpenVSwitch into Cumulus Linux?
So that's unfortunately a more complex answer than we can address in this forum. Again, a good question to ask offline. Maybe we have ways to communicate from this. We'll get back to you on that. The fundamental question to ask is, why would you want OpenVSwitch? If the requirement is to be able to handle some user space packet processing, clearly there would have to be some way for us to take a user space packet processing application and apply it to the forwarding ASIC. Otherwise, your CPU is not going to keep up with 48 or 96 10 gig ports worth of traffic. If you're talking about how to do Linux bridging or use Linux constructs, the Linux bridge is what we've been implementing and what we accelerate in hardware, because that's the closer and more realistic model that we can model around. A much more important statement that I'll make in there is OpenVSwitch today is a model that depends on which implementation or incarnation of OpenVSwitch you're using and which controller you're using, which takes away from the concept of Linux being a networking model and widely available.
Great. Next question. In terms of performance on a 4810 gig bare metal switch, how many packets per second can be routed in layer 3? And then how would that compare to other competitors?
So if you're looking at the switches that we provide, they're based on Trident 2. Trident 2 is a chipset that's used by everybody in the industry right now, whether it's an Arista, a Cisco, or everybody pretty much. So we're using the same chipset, and that's why it makes sense to look at industry standard switches, because they're really industry standard because everybody has the same chipset inside. So now the performance, data plane performance, is dictated by the chipset. The chipset can do, I believe it's 1.44 terabits per second for 10 gig, or
1.2, but yeah.
Yeah, so depending on the chipset that you get a capacity and a throughput that's dictated by it. So we have the specific data around the capability of the platforms that are documented on cumulusnetworks.com on our HCL. So if you look at the hardware compatibility list webpage, you're going to find a model that we support, as well as a hardware guide that takes through the details in terms of the support for each of the platform. And you can also look at all the data sheets for the different platforms. But the fundamental answer is it's the same chipset inside. So it's the same hardware capability. It's the same data path performance.
Great. Thanks, Srijit. Thank you, Orly. We're out of time now. Thank you, everyone, for your participation. We hope you found this presentation about open networking useful, and we'd love to have your feedback offered via the follow-up email. Please tune into our next webinar, November 20th, Open Networking in the Software-Defined Data Center, with VP and General Manager at Dell Networking, Tom Burns, and J.R. Rivers, co-founder and CEO at Cumulus Networks. Or you can join us each week for Coffee with Cumulus, and it's a product overview of Cumulus Linux. Details are available on our website at cumulusnetworks.com/webinar. Thank you, everyone, for your time today.